Time travel. Just the thought of it makes our minds race. What if you could step into the past and witness history unfold? Or maybe leap into the future to see how humanity has evolved? It's the stuff of science fiction, but is it only fiction? Time travel has fascinated us for centuries, inspiring books, movies, and endless theories. Yet beneath all the imagination lies a big question. Is it scientifically possible? Let's break it down. Time travel means moving through time the same way we move through space. But unlike space, time feels fixed, always moving forward, second by second. We wake up, live our day, and then time takes us into tomorrow. But what if we could disrupt this flow? Could we manipulate time, bending it to our will? In this video, we'll uncover the science behind time travel, explore real-world experiments that prove time can bend, and discuss the challenges that make this concept so tricky. We'll also dive into the biggest debate. Is traveling into the past even possible, or are we limited to small steps into the future? By the end of this journey, you'll have a clearer understanding of what's real and what's still science fiction. So, buckle up. We're about to embark on a journey through time where science and imagination collide. Let's start with what science says about time. Einstein's theory of relativity changed everything we thought we knew. According to Einstein, time is not a constant, it's flexible. Think of time as a river. It flows forward, but its speed and direction can change depending on the environment. This means time can bend, stretch, and even slow down under certain conditions. One of the key ideas is time dilation. If you travel at the speed of light, or even close to it, time would pass slower for you than for someone standing still. Imagine two twins. One stays on Earth, while the other travels in a spaceship, moving near the speed of light. When the traveler returns, they'll be younger than their twin. This isn't just theory, it's been proven. Astronauts on the International Space Station, moving at high speeds, experience time slightly slower than people on Earth. But there's more. Scientists believe that extremely massive objects, like black holes, can warp time around them. If you orbit close to a black hole, time for you would slow down compared to someone far away. This means you'd technically travel into the future because your time moves slower. The science is clear. Time is not rigid, and under the right circumstances, it can be manipulated. But how far can we push these boundaries? Can we use these principles to build a machine that moves us through time? The answers lie deeper in our journey. By the end of this journey, you'll have a clearer understanding of what's real and what's still science fiction. So, buckle up. We're about to embark on a journey through time where science and imagination collide. Time travel might sound impossible, but we already see small glimpses of it in real life. One of the most famous examples is time dilation, a phenomenon proven through experiments and space travel. Did you know that astronauts aboard the International Space Station are time travelers? Because they move so fast in orbit, time for them slows down ever so slightly compared to us on Earth. When they return, they're a fraction of a second younger than if they had stayed here. Scientists have also tested this concept with high-speed particles. In particle accelerators, tiny particles are made to move at speeds close to light. These particles live longer than they should, thanks to time dilation. This proves that time can stretch under the right conditions. Then there's the natural world. Think about black holes. These cosmic giants have immense gravitational pull, so strong that they can bend space and time around them. If you could safely get near a black hole and orbit it, time for you would move slower compared to someone far away. You'd be traveling into the future while the rest of the universe ages faster. All of this tells us one thing. Time travel, at least into the future, isn't just science fiction. It's already happening on a small scale. The challenge is making it work on a larger scale for humans. But what about the past? That's where things get complicated. If traveling into the future seems possible, why is the past so tricky? The answer lies in physics and logic. Most scientists agree that going forward in time, even by large amounts, could happen if we figure out how to travel close to the speed of light or use extreme gravity. But going backward, that's where we hit a wall. One popular idea is using a wormhole. Think of a wormhole as a shortcut through space and time, like folding a piece of paper to connect two distant points. But wormholes are incredibly unstable. The moment anything tries to pass through, they'd likely collapse. Even if we could stabilize a wormhole, there's the issue of paradoxes. Imagine you go back in time and change something significant, like preventing your own birth. This creates a logical contradiction known as the grandfather paradox. How can you exist to travel back if you erased your past? Some theories suggest ways around this. For example, the many worlds interpretation says any change you make creates a parallel timeline. So, even if you change history in one universe, your original timeline remains unaffected. But these ideas are still unproven. The debate continues. Is time travel limited to the future, or could breakthroughs in science unlock the past? For now, it remains one of the greatest mysteries of our time. So, is time travel possible? The answer isn't a simple yes or no, it's a not yet. Scientists are just scratching the surface of what's possible. The theories are promising, and the small-scale experiments we've seen, like time dilation with astronauts and particles, are proof that time can be bent. But building a working time machine, that's still a distant dream. The future of time travel lies in understanding the universe better. We need to unlock the secrets of black holes, wormholes, and quantum mechanics. What if one day we discover how to safely open and stabilize a wormhole, or invent technology that lets us harness the power of extreme speeds without harming the traveler? These ideas may sound far-fetched, but so did flying to the moon a century ago. For now, time travel belongs to the realm of science fiction. But every great scientific discovery starts with imagination. Perhaps in a few decades, or even centuries, someone will watch this video and smile, knowing we were on the brink of something extraordinary. Until then, all we can do is dream and keep asking questions. Who knows? Maybe the next breakthrough in time travel will come from someone like you.